All right. Section 2 is greatest common factor. We just have one vocabulary here. It is what is the greatest common factor, and sometimes that's called GCF. So I've abbreviated it there in parentheses. So if you see GCF, that means greatest common factor. So what is it? It is the largest, or you could say biggest, either way, the largest number which is a factor of two or more given numbers. And if you're not sure what factor is, you got to look back to the first section. Factors are numbers that fit inside evenly.
We did this last year.
I know. So this is a little bit of review from last year. So there's two ways to find these. The first way works really good with smaller numbers. The second way works really good with small numbers and big numbers. So you can use either way though. So listing factors, this is what we did yesterday. So first, list in circle is my first method. So you're going to list all the factors. So of 16, what numbers fit inside 16 evenly?
4 times 4.
So we've got 4 fits in there. And I don't have to write 4 twice because it's just 4 fits in there evenly. What else? 8 fits in there. So 8 times what?
2.
8 times 2. And I'm going to write them in numerical order. And what's another one that we need? 1 times 16. So those are my numbers. I don't think there's any more, correct? So now we do 24. What are the factors of 24? Sometimes it's easier if you list them as pairs. So 1 and 24. Does 2 fit into 24?
No. Yes.
Yes. 2 and 12.
So
Does 3 fit in there?
8 times.
3 and 8.
That's it?
Anything else fit in there? Does 4 fit in there?
Yes.
4 and 6. And that's it. So now you look at your list. So I have numbers that are in common. I've got 1s are in common. 2s are in common. 4s are in common. And 8s are in common. What is the biggest number that both of them have? Abdrell? 8. So the biggest number that both of them have in common is the number 8.
Yeah.
Okay. So that is the listing, encircling method. Okay? Whether it's a circle or a box or an underlined, it's listing and then finding from your list. The next method works nice for bigger numbers, works nice when you have more than 2 numbers. Has to do with making factor trees to start off. So first, we're going to write the prime factorization. And the easiest way to do that is to make a factor tree. So let's do number 12 here. What 2 numbers multiplied by each other equal 12? Liam? 2 times 6. 2 is a prime number, so I'm going to circle it. What 2 numbers multiplied by each other equal 6?
3 times 2. 2 times 3.
And those are both prime numbers, so I'm going to circle those.
That's it.
Let's do underneath here. Now let's write it as prime factorization. We have 2 times 2 times 3. You could also write 2 to the second power.
Wait, wouldn't it be... How?
Let's do number 24 now. What 2 numbers multiply by each other?
6 times 4.
6 times 4. Neither of those is prime, so we've got to continue each branch. What 2 numbers multiplied by each other are 4?
2 times 2.
2 times 2. Both prime. And 6?
3 times 2.
3 times 2. So underneath, we're going to list these. 2 times 2 times 2 times 3. Then we're going to do number 32, the last one here. What numbers multiplied by each other equal 32? 4 and 8. 4 and 8. We know 4 is 2 and 2. 8 is...
4 and 2.
So I'm going to circle my 2 so far, and then 2 and 2 here. So I have 2 times 2 times 2 times 2 times 2. And some of you would rather write that as 2 to the 5th power. That is totally fine. Either way works.
Wait, why is this, why is this to the second part?
Because you have 2 2's.
Yeah, but there's a 3 in there too.
So if I want to write these as powers, this is how I'd write them. This one would be 2 to the 2nd power.
Why?
I'm not done. Times 3.
Oh.
This one would be 2 to the 3rd power times 3.
Oh, okay.
This one would be 2 to the 5th power. Okay. So you found the prime factorization. Now, what is the same in every single one of those? Okay. There's a 2 in every single one of those. There's a 2 here, a 2 here, a 2 here. Are there anything else that's the same in there? No. There's not?
No.
Not 3s. The 3s aren't. So we got a 2. Are there any other 2s that are the same? Like this one has a second 2, right? And so does this one, and so does this one. So not 3s, and not the third 2, because the first one only has 2 2's.
What do we do?
So once you figured out what's in common, every single one of those has a 2 times 2. You take that, and you do 2 times 2, and that equals 4. So my greatest common factor is 4.
What? There's no. Okay, I'm just
The
gonna.
greatest common factor is 4. Let's do another example and see if we can.
Yes. I'm gonna be confused.
All right, so make your factor trees for 18 and 27.
Why can't we?
Or list, it's up to you.
Oh,
If you want to list, that's your choice.
I'm good.
So now that you've got your factor trees, what is the same in both of those?
Oh, there's 2 3s.
2 3s. You've got a 3 times a 3 and a 3 times a 3. So you do 3 times 3 equals 9. So my greatest common factor is 9.
Okay.
Third example's just got 3 numbers here again. So we already did 18. We know 18 is 2 times 3 times 3. We don't need to do the whole factor tree because we just did it on the one above.
Yeah.
Right? So we know that's 18. Have we done 24?
Yes.
We did that one on the other page, right? So 24 is 2 times 2 times 2 times 3. So 24 is 2 times 2 times 2 times 3.
Number 36.
Did we do 36?
No.
No, we didn't do 36 yet. So we got to do 36.
Oh, boy. 36. Oh, please.
So you could do 2 and 18 if you want, or 6 and 6. You could do 3 and 6. 2, 3. So now you're looking at 3 different ones and saying, what do they all have in common? They all have a 2, correct?
Yes.
They all have a 3.
So they all have a 2. And Zach says they all have a 3. Do they have anything else that everyone has? That's
That's it.
it. So 2 times 3 equals 6. So my greatest common factor equals 6. I like the factor tree way because I don't have to think about and I won't accidentally miss some factors. And I feel like for me, factor trees go pretty quick.
Yeah.
Some of you might like the listing method, and that's totally fine. You can use either method, okay? There's no right or wrong. All right, and then you might get a story problem in here. So let's think about this one. There are 12 boys and 18 girls in science class. The students must form lab groups. Each group must have the same number of boys and the same number of girls. In other words, each group's going to be made up of the same. What's the greatest number of groups that can be made with all the students being put in a group? So we've got to do the greatest common factor of 12 and 18.
Do we do 12 and 18 factor tree?
So we would do a 12 and an 18 factor tree. That's one way to do it. Or if you want to do the list method, you could do that. I'll do the factor trees just to show that one more time.
Everywhere. I want to try figuring it out. How would I?
All right, I'm going to stop right there. I'll let you guys go from there and see if you can figure out what the greatest common factor is. All right, so as I walked around, the ones I looked at, I think I got everybody's. You had 2 times 3 because they both have a 2 and they both have a 3. So that equals 6. So our greatest common factor is 6.